Right, hi everyone. So my talk is squash bugs with static analysis, and the whole purpose for this talk is appropriate application of static analysis reduces the overall cost of software development. And wherever you are along your journey of static analysis, from not using any to using quite advanced static analysis, hopefully this will convince you that using static analysis does reduce costs, and you'll have something that you can take away and kind of push whatever you're doing. You can move it on to the next step in the way. So how will static analysis reduce the costs of a bug, or reduce the costs of software development? Basically, if we think about how much a bug costs, if we find a bug at the moment we're writing the code, it's generally pretty quick to fix. You know, if we just immediately alerted, we've seen a bug, we can go, oh yeah, I've seen that, I'll go and fix that right there and now. If that bug lingers for a longer time, then it can take a lot longer to fix that bug, and therefore the cost of fixing the bug is a lot more expensive. Maybe the original developers aren't working on the system anymore, maybe it takes them a while to understand what they were doing, but generally it's an agreed trend that the cost of fixing a bug increases the later it's found. So what we're doing today is say, what can we do to take the expensive bugs and pull them down to the time where we're writing the code, and therefore reducing the overall cost. So that's how we're going to do it. We're going to look at techniques which will basically find our bugs earlier and thus reduce the overall cost of software development. So that's why we're here. We're going to talk very quickly about code quality. So in all software languages, you can choose to have high or low quality code. And in PHP, arguably more so, with some things like you can choose to have type hinting or you can choose not to. And it doesn't really matter where along that code quality line you're operating, as long as it is appropriate to the code or the purpose of the code that you're making. So if we think about something like the cost of a bug, if the cost of a bug is relatively low, it probably doesn't matter if we've got low code quality. If the cost of a bug is high, we need to make sure we've got high quality code, so the chance of that bug being introduced or is reduced. Same for project duration. The longer the project, really the higher the quality of the code has to be in order to support that project. And if you think about a number of people working on a project as well, if it's just you and you're writing a little script that's only going to get run once, you don't need high quality. You don't necessarily need high quality. But if this is a project that lots of people are working on, and it's going to be, project's going to run for a long time, and if something goes wrong, the cost is high, then we really need to be operating at the high code quality end of this line. And what I'm talking about today is these are techniques when you are wanting to produce high quality code. But I should just, before I move off this slide, just point one thing out. The nice thing about PHP is you can start off with, let's say, relatively low quality code, and the barrier of entry is a bit lower. So with PHP, as opposed to languages, for example, like Java, in PHP, you don't have to understand things like the type system. You don't have to understand things like generics to code away. Whereas if you want to start in a language like Java, this is kind of stuff you need to know from day one. So this is a great thing about PHP, is you can get into the language. It's a relatively low barrier of entry compared to a lot of languages, but then you can, if you want to, move your code quality higher, and as you learn more about it. But yeah, today we're talking about techniques if we want to produce high quality code. So basically, it's going to be my story when I went from no static analysis tools to relatively advanced static analysis tools. But before we start the story, a bit of a prologue. We'll look at what static analysis actually is, and we'll compare static analysis to testing. And as the story goes on, we've got lots of exciting bits like what is a bug and what tools can we use, and finally how we can baseline our legacy code and apply advanced static analysis to it. So who's telling the story? My name's Dave Liddament. You can find me on Twitter at Dave Liddament. I work for a small software consultancy called Lamp Bristol. and I help organise PHP Southwest and Bristol PHP training. Obviously, you know about those. Also been coding for about 15 years now. And when I'm not coding, you might catch me running or scuba diving, and that's a picture of me in the Scilly Isles a few years ago. But enough of that. This is why we're here. We want to reduce costs, and we're going to see how static analysis can help reduce those costs. So question one, what is static analysis? Well, let's do some static analysis together now. Is this code correct? I know it's 8:26, and I'm asking, but what do we think? Is this code correct? Well, let's do some analysis on it. Okay. So first of all, we have assigned the variable $A with the value 1, integer value 1. We're then going to call process. We're passing A to that, so we're passing to the function process the integer value 1. And what we can see here is that the function process takes a user. We don't know what that type is. As far as we can see, there's nothing wrong with this code. If we wanted to know if something was wrong with this code, we'd have to delve into the process function and see what it does. So as far as we can tell, this is okay. There's no obvious errors in this, apart from maybe some poor naming conventions. What about this code? Is this code? No? No? Okay, a few people saying no, so let's do the analysis again. Same as before, we start off with A being assigned the integer value 1. We call process, but we look at process, and process is expecting to be given something which is of type user, and integer 1 is not of type user. So what we've just done here, we haven't run any tests, we've just looked at the code, and we've just reasoned about it, and we can see that there is clearly a problem with this code. So static analysis is a bit naggy in a way, it's a bit negative. Static analysis just tells you that your code is incorrect. That's all it can do. It can't tell you that your code's working and it's behaving correctly, it just tells you you've made mistakes. Now testing is slightly different. So imagine we had this relatively simple bit of code. I make no excuses for the simple code, it's got to fit on the slide and it's got to be something simple that we can all process at 8:30 on a Thursday night. So it's pretty simple. We've got this function getPrice. It takes a type and it's going to return an integer, presumably the price. If the type is child, we set price to 10. If the type is adult, we set price to 20. And then finally, we return the price. So pretty simple code. And if I said, this is my test suite, I'm going to do 2 tests. First test, I'm going to pass in child and expect the value of 10. And my second test, I'm going to pass in adult and expect the value of 20. And as long as those tests pass, then we can say our code is working. And sure enough, if we look at this code and we had those 2 test cases, first of all our tests would pass. And interestingly, as the code is written here, we would have 100% code coverage. So every line of code will have been executed in those 2 tests. And not only that, all the if statements will have taken both the true and the false values for those as well. So on the face of it, this is looking pretty good. And the tests are telling us that something's working. So these tests can only tell us about the scenarios we're testing. So we only know when we give the value of child or the value of adult that our tests are working, that our code is behaving correctly. We know nothing else. That's all it's telling us. So what would static analysis make of this same code? What might it say? Yeah?
Handling a type that is teenager or not child/adult.
It would imply that through another way, but exactly that, yeah. So if we pass this into static analysis, it would complain here saying you could have price, which is an undefined variable. So if, for example, we pass teenager in, price would be undefined, it would be null. And if we look at the return type for getPrice, we're saying it has to be an int. It cannot be a null. So therefore, if we ran this code and we passed teenager in or OAP or whatever, it would fail. So this is kind of the two things. So static analysis are telling us our code's incorrect, and testing is saying only for the scenarios we have that everything's working correctly. So in reality, we need both these things, and when we're writing good test suites, what we try and do is we think about all the happy paths, we think about all the boundaries, and hopefully we do enough that if all the tests pass, we can say we're reasonably confident that our code's going to work, but static analysis might still find issues. So you might say, well, could we just do more testing? And then if we did enough testing, we wouldn't need static analysis. And the reality of the situation is that's probably not possible. You would have to think of every single possible way your software would be used from the start of its life till it's decommissioned and make sure that is tested. And in all non-trivial software, which is what we're writing, that's just not going to be possible. So I'm going to say no. We need testing, we need static analysis. Okay, so that's kind of the basics. This is why we're here, to see how static analysis can reduce the cost. So now we start with my story, and I'm a bit embarrassed by this next slide. This is some of the code I wrote when I first started. Context, it was 2005, and I didn't really know anything about PHP. There's lots wrong with this code, but there was also lots wrong with how I was developing the code. So I didn't have any tests. Well, my testing actually was I would change a bit of code, I would go into the browser and press F5 and hope there were no error messages. My editor, I was using Vim, and it didn't give me any useful syntax error highlighting. It didn't tell me that I missed a semicolon or I missed a dollar or anything like that. And also, I didn't have any other automatic linting of code. So that means that if, when I was trying out some new code, I didn't hit a line of code that was wrong, I wouldn't know about that until I actually did something that exercised that part of the code. So, I mean, essentially these two things are both looking at the code, but they're doing it at different times of the software development process. If you've got an IDE or a text editor or whatever you use to write code, that tells you in real time you've made mistakes. I'm going to call that real-time static analysis. And then the second of those things in the red box is what you do at continuous integration time. So you would commit your code, push it up to a CI server, and then it can do linting of the code as well. So it's kind of a safety net. So if we think about our cost of a bug, our continuous integration can only really reduce the cost of a bug up until the point it's run. So generally, I'm assuming that you're working on your code. When you think it's finished, you're going to push it up to the CI, and it's going to run its tests, and it's going to run anything else there, any other tools you have. But if we can do real-time static analysis, potentially we can catch bugs at the time we're writing them, and we'll see later we might not even introduce bugs in the first place. So our first takeaway really is you need to be using a tool, whatever tool you're using to write your code, ask these questions about it. Can it find bugs like this? Can it point out that I'm probably missing a dollar there? Can it point out that there's no closing semicolon on the end of this line? Can it point out I've misspelt return? Also nice, and we'll see why in a minute, can it just point out general typos? We'll see why that's important in a bit. So if you're not using a tool to write your code that answers this question, it can do all these things, then I suggest first thing tomorrow is to find a tool and start using that. Second takeaway is if you're not doing any kind of continuous integration at all, then start your continuous integration with just something that just does simple linting. So that's going to find things like, missing semicolons and stuff like that. My current tool of choice is Parallel Lint. Those are instructions on how you install it, run it. I'll make my slides available so you can have a play with it. So hopefully we can see, even if we're just doing those really basic steps of getting ourselves a proper IDE for writing PHP code, and we start up CI that just does some very basic static analysis, we will find some bugs sooner and thus reduce the cost. So anyway, that first project was a bit of a disaster. I did work on a few other ones, and it was getting better. And then I had a bit of a change in direction in what I did, and I got involved with doing technical demos of a tool that did pretty advanced static analysis for its time. It's about 10 years ago now. And it would do static analysis on Java code and C code and C++. And my job was to go around, someone would find potential interested people, companies. I would go to the companies, I would run the analysis tool on their code, and we'd have a discussion about whether they should buy the static analysis tool based on what it found. And obviously I was saying they should, and they had to be convinced. But we had lots of interesting chats when I was talking to people, trying to convince them to buy this tool. And probably the most interesting one was what actually is a bug. So subsequently, I thought about this, sadly not at the time, but many years later. I kind of think there's 4 kinds of bugs that static analysis tools will find. So we've got what we traditionally call a bug, like that example, that second code example, where if we ran that code, it would actually fail. We've got something called deferred bugs, evolvability bugs, and with static analysis, you always get false positives. So let's look at some of these bugs then. So this is a real bug. It's the one from earlier, because essentially we're trying to pass integer 1 into something that expects a type of user. Now, actually, in Java world and C world, you wouldn't actually get bugs like this because it's a fully strongly typed language. But these are the kind of issues you get a lot of in PHP. So this is definitely a bug. If we ran that code, it would fail. How about this? Is this a bug as well? I need to give you context. Can we see any bugs there? Yeah, so I've got a typo there. I've misspelt person, and then in the first bit of code, I'm trying to use person spelt correctly. Now, the interesting thing about this particular bug is it inspired PHP's first, what I would call, advanced static analysis tool. There's a chap called Matt Brown. He worked for Vimeo, and a really interesting post about it. He did this massive refactor, and at that time they didn't really have any kind of static analysis tools, and they didn't really have much testing, so they would make changes to the code, push it live, and pray that everything would work. And one time they did this, and it didn't, so they rolled it back. And what they found out was actually it was just a simple, they'd misspelt something. Their class was misspelt, and they tried to use the correctly spelt version of it. And he thought, this is crazy. Why have we not got tools that can help find errors like this? So he went off and wrote Psalm, and it's a fantastic tool, and we're going to look a bit more about it later. So, you might be thinking, no, I was trying to sell this static analysis tool that found bugs. How many critical bugs, how many real bugs did I find? And that largely depended on the project, like how long it had run, how many people, how much staff turnover you had. And generally, the longer it run and the greater the staff turnover, and generally the poorer the quality of the code was, which was good for me because they were more likely to buy the tool which found all their bugs. So I get more commission that way. Okay, but then we also had bugs like this. Is this a bug? Could this code ever become problematic? So any way we could execute this and it becomes problems. So what if I said, well, we'll execute it this way. We'll create a person, and then for whatever reason, we immediately call getName on it. So we go into getName. We can see that it returns name. We haven't set it up. It's expecting, getName is expecting to have a return type of string. At that moment in time, if we've just created person and the next thing we do is call getName, we'll have a type error because we're basically returning null, and our requirement is we return something that's a string. And then people argue, is that a bug? I mean, it's a bit like this. Is this really a bug? it's fine if we only ever called it with child or adult. And what often happens, we'd have discussions about this. I'd find some code that's a bit like this, and they'd go away and they'd come back half an hour later and say, this is definitely not a bug, because the only times I call get price, I give it child or I give it adults, and I've gone through and I've looked at it all. And I'll say, that's fine, it's taking you half an hour to establish that fact. Do we know from now till the end of this project's life, we will never, ever, ever call get price with something other than adult or child? And I go, can't say that for sure. And it took them half an hour. It took them half an hour to find out that it was an issue. So why don't you just spend that time fixing them anyway? So I kind of call these deferred bugs, and there might be a proper name for them. And I think generally these things, it's probably quicker to fix them than to risk it, especially if we're aiming at the high quality, end of our code quality spectrum. So we might be able to do things. I mean, this is just an example of how we could fix that issue. It might not be appropriate in all cases, but maybe we could say, well, I'll get rid of the setName method, and instead I'll have a constructor which we have to pass in a string value of name, and then there's no way that a person can ever be constructed with name in a null state. It has to be in a valid state. So that's one way of approaching it. You might be able to re-architect your code in such a way that prevents the problems in the first place. So deferred bugs are our second group of bugs. Our third group are evolvability defects. I'll read this out. So it's code that makes the code base less compliant with standards, more error prone, or more difficult to modify, extend, or understand. So it's a posh word for technical debt, and it's particularly important because people have studied these evolvability defects, and they found things like it actually accounts for a high number of the kind of defects you find in code review, and there were some costs associated with it as well. So, and I've referenced the studies. So if tomorrow you want to look them up online and then take them to your manager to argue about whether technical debt should be fixed or not, these studies are there to help back up your case. So a very silly kind of evolvability defect here. We've got the dot block saying it returns an int, but the actual method signature says it returns a string. In this case, the method signature is right, but having something in the dot block that's wrong is confusing, and somebody might look at it and do the wrong thing. Then we don't really know what $A is. I mean, $A is a bad name anyway. We look at the dot block and assume that it's correct, and we assume that it's of type person. But actually, when we go and look in the code, we actually find it's actually an object of age, whatever that is. So this is the kind of stuff, it might not actually break, but you are adding a load of technical debt in, and someone else will use this, and they won't really understand what's going on, and they're likely to introduce bugs. So we kind of have a list of the 4 kind of bugs that I talked about, and the final one's false positive. So things that the static analysis tool says is wrong, and it's definitely not wrong. So everyone agrees that the top one is definitely a bug. I kind of agree. I'd argue actually that the next 2 in that are also bugs, and if you can get rid of them, that's beneficial. It will save you costs. And even in the case of false positives, once you've been using some of these static analysis tools for a while, you'll understand what will cause it to be false positives, and then you can rewrite your code in such a way that won't trigger the static analysis warnings. And that probably is a cleaner way of writing it anyway. That's not always the case, but yeah. So anyway, I'd be selling this tool, I'd go in, I'd analyze that code, we'd have an argument about what bugs have we found, and then eventually they'd say, okay, well look, I've got 3,000 of these things. Do you really expect me to go and fix all these bugs before developing new features? And one great thing about this tool that I used to help sell is I say, no, just do all the critical things, all the really urgent ones, and then maybe you can chip away at the others as you go along. And have this great thing where it could just baseline the results. So it would say, oh, I've seen this bug once, but I don't want to see it again. I don't want this thing reported again. And it was clever enough, so even if the code moved around, it still kind of knew that it had seen it before. Don't know how it did it, but anyway, pretty impressive. Anyway, it turned out I wasn't very good at convincing people to buy this tool, so I returned to software development. And I went off and did Java development for quite a few years, and it's quite a mature language. It's got lots of great things. There's a thing called Maven, which was a package manager, which was amazing. Eclipse was a great IDE, and Checkstyle was great just for kind of like low-level static analysis, making sure that your code all conforms to the correct standards. And about 5 years ago, I got an offer to come back to do some PHP development, and I was kind of in two minds about it. But I had a look round, and in that time I'd been away, PHP had come on massively. And probably the biggest thing I think is Composer. It's such an important tool, and I think it's really pushed the whole PHP community on. So what I wanted to do was say, well, these are great things I had while I was developing Java, and what are the equivalent in PHP world. I replaced Eclipse. It did actually have PHP, did understand that, but it wasn't great on PHP. So now I'm settled on PHP Storm. And Checkstyle, now I use the Friends of Symphony PHP code style fixer. But probably the biggest takeaway I had from my Java days coming back to PHP was just type in everything. And when I returned to PHP, it was still PHP 5, so your type hinting was a bit limited. You couldn't, for example, type in scalars, like ints and strings, and you couldn't define what your return type was either. But you could put it in the doc block, and your tools like PHP Storm would understand all this and do all the clever static analysis that you would get in Java world. So if you're not already type hinting stuff, my next big takeaway would be to start putting type hints all over your code. Now, hopefully, we're all at 7.1. It's great. You can pretty much type in anything you want, apart from generics, which we'll come on to. And then, if you start doing this, you really get the best out of your static analysis tools, your real-time static analysis tool. This is a screenshot of the code we saw earlier, but looking at it in PHP Storm, and it's telling me, the moment I've written the code, that actually I cannot possibly pass $A into it. It's got this little, it's kind of highlighted it in yellow, and it's telling me it's expecting there to be a type user, and you're giving it an integer. But better still, as I'm typing the code, it tells me what it's expecting. So I'm not even going to introduce bugs in the first place if I type in everything and I look at what my IDE is telling me. And the other kind of productivity helpers it has is because it understands what's going on, it says, well, I know this analysis results object, I know what it is, so therefore I can tell you all of the possible methods on that particular instance of the class. So hopefully you can see, if you start doing these things, if you use good tools, and if you type in everything, we can start taking bugs that we wouldn't find till way in the future and potentially not even introduce them in the first place. So this is a big win. My requirements for a static analysis tool, it has to understand the code base, including everything in your vendor directory. It has to highlight the errors in real time. It should suggest and autocomplete based on the context. So it should understand enough to give the correct suggestions. And we haven't really looked at it, and we're not going to look at it today, but it should be able to help you out with refactoring as well. So if your IDE understands your code base in its entirety, then you can go, I've misnamed this class, I'll name it something better, and it can safely refactor everything. So hopefully you've seen, if we type in, if we use the good tools, we're going to find bugs earlier, so we're going to reduce the overall cost of our software development. So I've been coding along in PHP for a few years, and this is probably where I was up to about a year ago, and I was generally pretty happy. PHP Storm was pretty good. It was helping me find loads of things. Went through various continuous integration tools, currently on Circle CI. I don't have anything to do with either of these tools other than I use them, and I think they're quite good. If you're not using any CI at all at the moment, and you've got your code in, say, GitHub or Bitbucket, then have a look at Circle. It gives you something like 1,500 free build minutes every month on private repositories. There's a little link there to a skeleton project which shows you how to set something up and shows you how to put in the basic continuous integration thing. So if you're not doing CI, have a think about that. It'll probably take you half a day to set up just the absolute basics, and then you can build on that as you go along. And these are the kind of things I currently have in my tool set. It was only about a year ago I actually put the composer validate into it. But these are kind of things. So you've got a parallel lint, which we talked about earlier. CS fixer means you can enforce everyone on the team follows the same coding standards. There's PHPCS, which essentially does the same thing. Doesn't matter which one of those you use, but have something in there. Var dump is quite good if you are a bit sloppy with your debugging like I am and just litter the code with var dumps, because this will point out you've left some behind, which is handy. And based on our first talk today, have a look at the Sensio Labs security checker. If people raise security alerts on particular packages, what this does is it looks at your Composer JSON file, works out what packages you've got installed, and then cross-references it with a list of known vulnerabilities, and then alerts if there are any issues.
It's pre-installed into GitHub now.
Oh, it's pre-installed into GitHub, brilliant. Yeah. Oh, fantastic. There you go. So it's pre-installed into GitHub as well, but I definitely have it as part of your CI, and it's the kind of thing you probably just want to run that every week, just to make sure you've got nothing new coming in. There's also, if you Google PHP static analysis tools, you'll find that link at the bottom, and it's got probably over 50 different static analysis tools on there. It's an incredible resource. Have a look at it and start introducing, get the basics in your CI and start introducing additional tools as you need them. For the Symfony developers, I haven't moved to Symfony 4 yet, but these are the things I use in Symfony 3. All available by the console command. So again, if you're using Symfony, just drop these in, quick wins. But there was still this nagging problem. I had some pretty good real-time static analysis in PHP Storm. All that kind of really advanced stuff that we were, where it would find out things like, I was calling a method that didn't exist on a class or that kind of thing. But that wasn't being replicated in my continuous integration environment. So it was fine if everyone was using PHP Storm or whatever they were using, and they were religiously checking that they hadn't put any errors, that there were no errors reported. But people make mistakes, and people forget. And maybe they're refactoring something over here, and something over there is now broken, but they forgot to look at it. So what I really wanted was to replicate that kind of advanced static analysis as part of my continuous integration. And about a year ago, I was at a conference, and Rasmus was having a talk, and he mentioned this tool called Phan. And I looked at it, I thought, that's exactly what I'm looking for. It does a lot of the kind of advanced static analysis tools that things like PHP Storm do for you. And actually, I discovered there was another couple as well. There was Psalm and there's PHPStan. And these essentially, they all do the same thing. They all are amazing tools, and I think it's all worth having a look at. So I'm mainly going to talk about Psalm, but what I'm talking about Psalm is kind of applicable to all three of them. So the first thing is you can go to the Psalm homepage. It gives you a code editor. You can just put some code in, and it tells you pretty much in real time what issues it's found. And this is the kind of stuff it will tell you, this is exactly what it'll do when you run it as part of your CI. So if you ever want to try something out, you can just go to this code editor screen, put some code in, and see what it makes of it. PHPStan has similar kind of thing. Again, just put your code in, and it tells you what it would do. So there's some common concepts between all of these tools. The first thing is they all have this concept of levels. They go from a least strict to a most strict level, and what happens is every kind of level of strictness you increase, you're adding in more and more checks. And the authors of the tools kind of work out what they think is sensible for each level. And the reason they do this is so you can start off on big code bases, which maybe haven't had any static analysis done on them, maybe at the least strict level, and just see the most critical bugs, and then you can slowly kind of push up the level that you're operating at. Or if you're going to start greenfield, then I go for a much stricter level. It kind of depends where you are in your development process. So anyway, they've all got these levels. And another common concept, and this is something that's essentially currently missing from the PHP type system, but hopefully it will get added maybe in PHP 8, who knows. It's the concept of generics. So if we look at what's going on here, we're basically iterating through, we've called the getEmployees method of the business class, and we're iterating through each one. So we have type hinted it, the getEmployees, so we have said we are returning an array. So we know that we can iterate through it, but we don't know what each entity within that array is. So we basically don't know what employee is. We'd have to go and look at the code. So that means if we want to call promote, we don't know that we can't say for sure that we are calling promote, passing to it an employee. So there's a way we can get around this, and you've probably seen this if you've done lots of PHP code. You can say in the dot block, you can say, I'm returning employee in open and close square brackets. And what that means is we're returning something that's iterable, and the value field of that is of type employee. And that means our IDE knows that this is an employee, which means it knows that it's passing to promote something that is of type employee, which means that we know we're doing the right thing here. And if we ever tried to pass something that wasn't an employee to promote, then our static analysis tools would tell us we've made a mistake. I possibly made a mistake there on that. So, and even tools like PHPStorm understand this. So here we can see, got the var employee bit here, and I can see that I've just hovered over employee and it's telling me employee is of type employee. So it understands it, which is good. So you then get all your auto completion and everything else. So that's all very well, but what happens if we modify our code like this? So now we're iterating through our employees, and we know that we're getting the key, which we've called name, and we've got the employee. So we know, and then what we're doing with the name is we're passing it to a welcome method, and we can see that the welcome method takes something of type string. There is no way of knowing, with the code documented how it is at the moment, that the key of the thing we're iterating through is of type string. We cannot, with the code we've got on this screen, we cannot assert that's the case. And if we pass this into something like Psalm, it would actually say something like this. It would basically say, argument 1 cannot be mixed. So what Psalm does is, if it doesn't know the type of something, it just assumes it is of type mixed, which could be anything. So how can we fix this then? Well, there's an alternative notation we can use for generics, which looks a bit like this. So we've got array, we've got open angle bracket, string, comma, employee, close angle bracket. So the first thing, the string, is saying, this is an array where our values are all of type string, our keys are all of type string, and our values are all of type employee. And now Psalm understands that. So it knows that name is of type string, so it can say that what I'm passing to welcome is of type string, therefore we are calling welcome correctly. That's all fine. However, right now, PHPStorm doesn't understand that. So there's our improved way of writing our generic. But we see it's got employee mixed. So it's not clever enough to know, it doesn't understand this way of expressing generics. Now, I think that is changing soon. I think there's an early release of PHPStorm where they might start looking at this. And also, there's this PSR5, which actually specifies this is how we're going to document generics. Sorry, I've got my stuff in the wrong order. Yeah. Oh, yeah. Sorry, got confused there. Right. So you might say, okay, well, that's fine. What do I do if I want to do generics where I want to specify both the type of the key and the type of the value? Because I don't want to be in a situation where PHPStorm doesn't understand things. I would take my real-time continuous integration working over the stuff I put in the CI. sorry, my real-time static analysis, I take that over what I put in the CI. However, SARM has got a solution to this. If you can put basically the return type, which is what PHPStorm will understand, and then you can do this thing where you say SARM return, and then what the SARM does is it says, well, I'm going to ignore the normal at return annotation, and instead I'm going to use this. So it keeps both your PHPStorm happy and also SARM happy as well. In reality, most times when you're dealing with things you're iterating through, you don't really care about the type of the key. You're just iterating over the value. But yeah, this is PHP 5. It's quite exciting. In the last week or two, they've announced that they're now resurrecting this, and hopefully it will become approved soon, and then tools like PHPStorm will catch up. So basically what you can do to help out with generics is where you've got var, param, and return. In SARM, you can have SARM var, SARM param, SARM return, and same again in Phan. So this is a way how you can give additional information to those static analysis tools. Other common things you can do, we kind of mentioned at the start, you can kind of set the level that they operate at, so to pick which, how pernickety it is about its analysis. If there are things which you don't want to fix or are false positives, you can do annotations to say suppress particular warnings. Through config, you can ignore certain directories, you can turn off certain types of errors it reports, and you can say, well, you can even be more fine-grained than that. I want to ignore this type of error in this kind of directory. So if you want to get started with one of these tools, which is what I would recommend that you do, first of all, just install it, simple as that. Then often what they do is they will have config files, and they've all got various ways of generating the config. This is how you do it in SARM. You just call init. You give it the directory you would like to analyze and what level you'd like it to operate at. That creates the config file, and then you just run it by calling SARM. And then probably your next step is to cry when you see the results. So here are some results I had, and this is a project that I worked on maybe about a year ago. We did it all in PHPStorm. We were pretty good with the code reviews. It had a reasonable level of testing. I thought it was pretty high quality code. And these are the results for each of the levels it came up with. So at level 8, its least strict level, it still found 30 issues. And when we got to level 1, it found something like 1,500 issues. So the question is, were these real bugs? And it did actually find a real bug. So here we've got some code. What we did is we had some stuff stored in JSON. We converted it into an array, and then we'd iterate through the array to pull bits out of the array. And here we are trying to get the email address out of the array. So kind of working back. The thing we would expect to get from the get email address is something of type string. We see that we're returning email. And when we're getting email from the row, and we're looking somewhere in that data structure. Now the point is, something in that is JSON, so not everything's a string. We could have something that is a number, an integer, or something like that, or a Boolean, or a null. So I did do some kind of checking. I checked that did exist, and if email didn't exist, I would throw an exception. And the whole part of this import entity exception was it would get caught by the thing a bit higher up, and then it would work out how far through the JSON file it was and give you some context, so it's much easier to find the bug. But what would be happening here is if I'd given an email of the number 7, say, we would get a type error, and we would get no context as where it is. So we would have to go through that whole JSON document to try and work out. Whereas I'm not trying to do that. I'm trying to give as much information as possible, so if someone gave something that wasn't valid, we could find it easily. So I was going to say is a real bug. We kind of had quite a few deferred bugs. So what is going on here then? Why is this a deferred bug? Well, I'll put you at the start. So, sorry? Yeah, so it's possibly we're going to put in a null value here. So look, we're calling create search criteria, we're passing to a postcode and whatever the response from location get slug is. We can see that it requires to be of type postcode and specifically string, but not nullable string. But we can see that get location actually could return a null value. So this could be an issue. Was it an issue? I don't know. I had to spend a long time working through the code to see if that really was an issue or not. But it's the kind of thing that could, if it's an issue, catch us out one day. So yeah, I'm going to say that is a deferred bug. We've got another deferred bug here. It's pretty similar to what we had last time. We're iterating through a series of locations. We can see that our function location returns us an array or a nullable thing, which is a pretty bad. I don't really know how this got through code review, really. I think if you're returning some kind of collection and it's empty, you should just return an empty collection. But anyway, again, would this ever return, would get locations ever return null? I don't know, I'd have to work through all the code. So it's better to fix the code and stuff like that. We had an evolvability defect here. Can anyone see what that evolvability defect is? Well, so I had type hinted our anonymous function with bookmark, but what I hadn't done, and this is PHP 7.1, I hadn't said what the return type was. In fact, until I saw this warning come up in SARM, I didn't even think or realize that you could actually apply return types to anonymous functions. I mean, there's no reason not to, but I hadn't thought about it. I never had done, and now I've seen this, I've learned it's improved my PHP. But again, I still had 1,500 bugs, and I was thinking the kind of things I would say to, people say to me when I was selling the static analysis tool, you don't really expect me to fix all those 1,500 bugs. I mean, this 1,500 bugs, this is code that's in operation. It's been in operation for a year. We track the error logs, and we're not really getting any issues with it. So the reality is, if you run this on code that is legacy, and in the terms of static analysis, legacy code is any code you've written without static analysis tools on it. I didn't really expect you to fix all these bugs, but here are some tips to how we can reduce the number of bugs that we find. So the first thing is if we target our business logic. So when we're writing code, we've got a lot of code that's attached to the framework, and we've got a lot of code which is business logic code, which is our core code that we're really interested in. So you might have seen this. There's things like hexagonal architecture and layered architecture. And basically layered architecture, the inside knows nothing of the outer layers. So the business logic knows nothing that it's a web application sitting in whatever framework it is. The outside world knows that it's talking to a framework, and the framework knows that it's talking to the business logic, but not the other way. So the business logic is the stuff that you've all written, specific to whatever problem you're trying to solve, and that's probably where we need to be our most strict in our static analysis. We can be a lot less strict about the stuff that's connected to the framework, because that's, if it's an established framework like Symfony or Laravel, it's pretty well tested, and you probably don't have to be as strict there. And a lot of the issues we've got in our 1,500 issues were we're integrating with a kind of framework called Sonata. And there's nothing wrong with Sonata. It was just written in a time where people didn't do this kind of static analysis. So it wasn't code that would be resilient enough to this kind of analysis based on it. So yeah, first of all is have your business logic and really target that with the strict stuff, and be less strict, or maybe don't even bother with the stuff that's just in your framework. And hopefully you've kind of separated out your code in that way. The other problem we had quite a few times with is we were using a third-party library, and this was something hasher, so it would take a string and then it would give you a hash of it. But if we look at and we would call it by calling the encode method, and you would put in whatever you want it to encode. But if we look at the signature for the encode function, it looks like it doesn't take anything. In fact, you even read the doc block, and it doesn't mention anywhere that encode takes a parameter. Yet we're calling it with a parameter. So when we call this, our static analysis tool will complain about that. So what you can do is then basically have a wrapper for the third-party code, and you just say, I'm just going to ignore any kind of issues that our static analysis tools raises about that, but I've given it a clean interface, which is what I'll use everywhere else. And maybe you put your third-party adapters in a layer which you don't apply such higher level of static analysis to. So the key thing really is you apply this kind of static analysis to your code, and these are the kind of things you kind of want to do. Don't be sloppy with your code. Architect your code better so you get fewer static analysis violations. Type into everything. Type into your properties. Use the dot blocks where you can't do it at language level. Learn from your static analysis problems, like I didn't know you could type hint closures. And if you're not going to return anything, then be explicit about that and use void if you're on 7.1 or above. And you might say, well, is this all really worth it? It sounds like a lot of effort. And I think it is worth it, because what happens is you've got your code and you improve your code in such a way that humans and static analysis tools can understand it better. And that means we can use our IDEs, because it understands the code so well, it can do refactors for you, which makes it even easier for humans to understand. And you kind of just keep going around this like positive spiral upwards of code quality increasing. So hopefully you've seen that if you do these kind of things we've talked about, static analysis can help us reduce the cost of our software development. But there was still this real big problem. I had this huge code base, and it had 1,500 errors in it. What do I do with that? What I really wanted to do is say, well, I'm going to go and fix all the critical things, the things I think are really important, and then I'll go back and fix the other things as we do more work on it. But what I really want to be able to do is take a baseline of our static analysis results. So we've got a commit, and we say, look, here are all the problems. We've done all the fixes we're going to do, and we've got 4 or 5 problems, or however, 400 or 500 problems that we're not going to fix now. But I don't want to see them in subsequent times when I run the static analysis. So I do some more code. Maybe I've got even more problems that time. Maybe some I fixed, and some I've added as new ones. What I really want to see is I'm only interested in seeing the new violations, the new static analysis issues that it has raised since I took my baseline. I remember the tool I was telling you about at the start, it did all that. But I couldn't initially find any tools that did this in the PHP world. So what I'm really interested in, I've got my baseline. I never want to see those errors again. I just want to see the new ones I've introduced. So there wasn't anything yet. Hopefully I'll find something it is, because I've started writing my own. Use it internally, and I will open source it. It's called SARB, which is Static Analysis Results Baseliner. I'll tweet round when I've actually finished it off. Currently it supports SARM, and it will support the others. And you can easily write things for your own tools. And it doesn't actually have to be anything to do with PHP. The only real requirement is it's stored in Git at the moment. Your code is stored in Git. So how do you operate it? Well, first of all, you'd create a baseline. So you'd run, say, SARM, get your results, and then you would say, I want to create a baseline based on these results, and it would store it in the baseline file. And it would say, baseline's created, and there's 328 issues it's found. Then you would go and do some more work, have a new commit, or have several new commits. You'd rerun SARM again, and then you'd run the SARB in its remove baseline result mode, and you would give it an output file. So it would take the baseline, it would take your latest set of results, and then you'd give an output file, and this would be basically the results with all your baseline removed. So you'd end up at the bottom and say, well, since these 2 commits, I found 338 issues, but only 15 of these are new ones. And that's where you'd focus on. So basically you say, I've got all these issues, but I don't want to make anything else worse. So kind of how does it work? Well, what SARB does is it looks at the baseline, and it goes for every vulnerability, what's its type, and where's its location, what file and line number is it in. So let's say we've got these 3 issues it finds. And then this is my code, and let's say I've got some issue here. At line 93, it's an invalid nullable return type. I go and do some more work, and as part of my work, I delete in this person class 20 lines of code. So now we're at line 70. So the issue we had before has now moved. We're now at line 73, and it's invalid nullable return type. And that's the one that we basically saw previously, but it's moved because of some of the edits I've done. So what would happen is SARB would basically go and take the latest set of results, and they'd go through each result in turn and say, look, I've got this problem. There was this invalid nullable return type at line 73 of employee. And it would say, what was line 73 of employee in the baseline. And then we'd go off to the history analyzer, and the history analyzer would say it was in line 92. Line 73 of employee was at line 93 in person in the baseline. And then it would say, okay, in the baseline, did we have a problem of type invalid nullable return type at line 93 in the file person.php? And we go, yep, we did. In that case, it's in the baseline, so I'm not going to report it. And then if it didn't find it in the baseline, it would say, well, this must be new, so I'm going to add it to the list of new things. So how you'd kind of run with Saab, which will honestly be released soon, you would run the static analysis tool for the first time on your code, wherever it stands. You'd fix all the bugs that you decide definitely need fixing. You would run the static analysis tool again, and that would be what you make your baseline of. And then you're kind of basically in this loop forever, where you write code, you run the analysis, you strip out the baseline results, you fix the bugs. And that means wherever state your code was in, it's not going to get any worse, and you're not going to introduce any more of these kind of bugs. So basically, you can be happy. And that's kind of where I am now in my static analysis, and what an adventure it has been. So hopefully you're convinced that if we do static analysis properly, we can reduce the cost of software development. Remember, static analysis just nags you. It just tells you that your code is incorrect. Tests tell you that for particular scenarios, your code is working correctly. Cost of a bug escalates the longer it takes to find it. So basically, if we can use real-time static analysis, we might not even put bugs in the first place. We still need that safety net of a continuous integration to catch anything we don't catch when we're using the tools. But these, in combination, reduce the costs of bugs by basically finding them earlier. So my current CI toolset is this. Again, check out that link for the static analysis tools. If you're thinking my IDE doesn't live up to scratch, these are the requirements that you need. It's got to understand the code base to help highlight issues, to auto-suggest, and to help you refactor. One of the tools you can use is PHP Storm. If you don't have it and you want a license, then don't forget to give feedback, because then you might win it. Once you've got all that going, then do think about looking at adding more advanced static analysis to your CI with things like SAM or Phan or whatever you want. And that is it. So thank you very much for listening. Any questions? Yes.
It's not really a question, just comments. So we use Phan,
Yeah.
and one of the things that you can do with Phan is tell it the version of PHP that you'd like it to check against, and even if you're not running that, it will tell you what the violations would be.
Yeah.
So we used it for upgrading from 5.6 to 7.1, and you can do that for like 7.2, etc., which is quite useful.
Yeah, so these tools you didn't hear about. These tools are pretty good. They can help you out with many things from upgrading, and the more information you give it about the environment that you're trying to test, trying to analyze, the more accurate its results will be.
The other one is about the baseline. Sorry.
Yeah.
So I don't know any static analysis tools which do the baseline thing you were talking about, but there are some CI servers that will do it for you.
Yeah.
So like Travis, for example, you specify the amount of after running the CI tool the static analysis tool once, and you get your overall amount of violations. You just say, you give it a threshold, and you say, tell me if the amount of violations goes over an additional 30 violations than the current number, for example. So it's not quite as clever as the tool that you're talking about, as the one that you've created, but at least it will tell you if you go, like if you suddenly shoot up with the amount of violations that you do.
So I did. So yeah, I mean, the Saab is one way of approaching how we make sure we're not getting regression. So one way is you can just do a simple count of violations. But then what you might do is fix a load of really essentially low priority ones. You might, if your number's 300, you might fix 10 really low priorities, but introduce 2 really high priority ones. So your number's gone down to 292, but you've actually introduced 2 pretty substantial ones. There are other ways I mean, how the static analysis tool vendors suggest is they say, start off at low level, finish all those off, then keep escalating the level, and then over time, your code quality will get higher and higher. But the problem I have with that particular approach is that, again, you might say I've got rid of all my 8 and 7 level ones, but I might be introducing some really critical, level 6 or level 5. So, and even the approach I'm taking isn't perfect. It's just combinations. Any others? We've got to wrap up. Yeah.
There's any more questions?
Any more? Yeah.
Do you think using more static analysis encourages lazier testing?
Okay, so the question was, does more static analysis encourage lazier testing? I'm going to say effective static analysis potentially reduces the test space that you need to do. So, for example, if you had a method that, did something with a string, and you didn't type hint that method took a string, then you'd have to write tests to say what happens if I give something that isn't a string in there. But I would say you'd be writing high quality code by enforcing it at language level that you have to take something of type string. So you therefore need fewer tests to prove that your code is working correctly because your test space is reduced. But I don't see that as being lazy. I mean, if you count lazy as writing fewer tests, then yes, it is lazy. But I see it's using tools effectively to reduce the testing burden. Does that kind of answer the question?
Do you think it would give people a false sense of security that their code is good?
Yeah. So if your static analysis all passed, would you get a false sense of security that your coding is good? Possibly. But as I said, static analysis tools is only telling you that you've made mistakes. You still need the tests to assert the behavior is correct. So I think sometimes people with static analysis may focus on things that are lower importance. They might spend hours fixing pretty low-level things when they should be writing tests, which maybe it's a bit more effort to write tests. So you do sometimes get that, but I think, you've just got to, if people start doing that, just guide them the correct way and say you've still got to write your tests. But static analysis does help reduce the number of tests you need to write. So yeah, is that cool? Any more? Yeah, at the back.
This is something that Scott put this week. We use PHPStan analysis, and also a lot of people we have using PHPStan. What approach do you take for documenting exceptions which bubble up the chain? So the throws tags in PHP or if you have function C which throws an exception, then you have then function B which calls function C but doesn't catch that exception. Would you be looking to document that it also throws that exception? Do you find that useful or?
So yeah, the question is about if you've got a function that throws an exception, and that exception can bubble all the way up, you can document it. You can either catch that exception and do something with it, or it will leak out of whatever method it's in. You can document with the doc block, say at throws, and then give the exception name, and then that means that your PHP Storm knows that you're aware of this function you're calling does throw an exception. So I think the answer to that question is there are some things you want to know about and others that you don't. And in Java world, they have this concept of checked and unchecked exceptions. So an exception I wouldn't really care about is, I don't know, like a type error. I don't really care about that. In fact, arguably, it's not an exception. But that I wouldn't really worry about because that's a coding error, and the only sensible thing to do is to stop execution of code, put something in error log, and have something, have some system where that gets reported back to the developers. And anything like a failed assertion, I would say that all fits into that bracket. These are coding errors that we're never going to recover from. But then you have things which are a bit less clear-cut, like what happens if you lose connection to a database. Realistically, 9 times out of 10, I go, I don't care. I'll just log that. There's probably not much I can do with it. Maybe I will, if it happens a lot, I'll go and investigate. In terms of how I do the reporting in PHP Storm, I just switch off that warning because I don't find it very useful, because there's not really PHP's exception handling isn't really mature enough to say, this is one that I expect someone to handle, and this is one that I expect to bubble all the way up and essentially just gets caught on some exception handler and logged. So until you're in a situation where you can specify on an at exception level whether this is something you want to catch or not, then I don't think there's any it's just polluting the code. But others will disagree with that. That's just my opinion. I don't know. You might agree or disagree. I don't know. But yeah. I'm going to say there's no correct answer to that one. But yeah. I mean, you could, for example, if it's your particular application, you could have a base exception that extends exception. And you say anything that throws that should be caught within the code I'm doing, and anything else where there shouldn't be. But honestly, I don't do that. But yeah. Right. Okay. If you don't use PHP Storm and you want it, then give some feedback and you might win a license. If you've got any feedback, that'd be great. Either joined in or my DMs are open, so you can just message me. And I won't really be offended whatever you say, as long as it is constructive. So ideally, if you can find at least one thing you liked, that'd be great, but that's optional. But what I really want from everyone is that just one bit of advice in how this can be improved next time. So that's me done, and those are the references. Thanks for listening.